Welcome student to our today's class. In our today's class, we are going to talk about the linear equation, which is actually a continuation of what we did yesterday. But yesterday we looked at linear equations where we have only one unknown. But in our today's class, we are going to look at the linear equations where we have got two unknowns and we need to get the value of those two unknowns. So you can find equations like this. You are given equation like maybe m plus n is equals to 3 and m minus n is equals to 4. These kind of equations are known as the simultaneous equations. The simultaneous equations, which need to be worked on so that we can get the value of the unknowns. And in this case, the value of our unknowns are m and n respectively. But note here that there is no way we can be able to get the value of these unknowns with only one equation. If we have got two unknowns, then we need two equations for us to be able to determine the values of these unknowns. Therefore, these equations are normally solved simultaneously using the following methods. Number one, we have got a method we call elimination method. We have got number two, a method called substitution. These are the two methods that we are going to focus on, though we have got the other methods we call the matrix method, and we also have the other one called graphical. At our level, our concentration will be on the first two, solving simultaneous equations using the elimination and the substitution method. Today, I want us to focus on working on simultaneous equations when we are using the elimination method. From what we know, the word elimination simply means that we are making something to be out of existence. We eliminate it. So in this case, our focus is normally to make sure that one of the unknown is actually reduced to 0 so that it does not appear in that particular equation. So the best thing here, we normally subtract. Like in this case, focus on the unknown that you want to eliminate. Here we have m or n. Which one do you want to eliminate? The one that you want to eliminate, is actually reduced to 0. The one that you want to eliminate is normally reduced to 0. So here, we can make this m to be 0 easily than n, because we can simply minus m so that we have the 0. So we can come here and subtract these two equations. Remember, this equation, we can define it as our equation number 1. This one can be our equation number 2. If we have equation 1 minus equation 2, we are going to have this m minus m is going to be actually 0, and n minus negative n. Here, remember, you must be very careful there. It is n minus because of this, and then what we have here is a negative n, which is actually going to be n, and negative and negative is going to give us positive. So we are going to have n plus n, which is actually 2n. So here we are going to have a positive 2n is equals to 3 minus 4, which is actually negative 1. So we shall find we have this equation here, 2n is equals to negative 1. So n will be equal to negative 1 over 2. That is by dividing everywhere by 2 by 2. That is actually a case where we have eliminated the m and making sure it is 0. We can find another equation where you are given this. You can be given something like this, or an equation like this, like 2x. We are given 2x plus, 2x we are actually doing the 2x plus 3y is equals to 600, and we have another one here, x plus 2y is equals to 350, and we are supposed to get the value of this unknown, that is the value of the x and the y. So what you need to do here, you can come here and make one of the unknowns to be the same. Like here we have got 2x, here we have got 1x, here we have got 3y, here we have got 2y. If we choose to eliminate x, then we should have both x's having the same value. So the easiest way we can do this is by multiplying here by 2, so that here it can be 2x, which is similar to what we have here, also 2x. So the first equation, equation 1 here, which is that, and equation 2, which is this, the first equation will remain the way it is, which is 2x plus 3y is equals to 600. And here, 2 will multiply everywhere, so that we have 2x plus 4y is equals to 700. Then if we subtract this now, we can subtract these equations because we have got 2x and 2x. We'll find that this one will be 0. 3 minus 4 is actually negative y is equals to, this one is the same as a negative 100. So you have negative y is equals to negative 100. Therefore, we can divide by negative 1 by negative 1, so that y is equals to positive 100. After getting the value of y, you can go to any of these equations that we have here and you substitute this. So you can come here and you say substitute y is equals to 100 in equation. We can do it even in equation 1. So where we have y, it is already known it is 100. So we just replace it with 100. So we are going to have 2x plus 3 multiplied by 100 should give us 600. Therefore, 2x plus 300 is equals to 600. So 2x, let us take positive 300 to the other side so that it is negative 300. So it's going to be equal to 600 minus 300. Therefore, 2x is actually going to be equal to 300. We divide by 2, so x is going to be equal to 150. So we are able to get the values of the x and the y like that. So that is how we work it. And I think we can do the third example, still using the elimination method, where you are given this equation. Equation number 1, it says like this. It is 4x minus 2y is equals to negative 3. And 3x plus y is equals to 3. This is actually our equation number 2. And you are told you use the elimination method to work out for the values of x and y. So what you need to do here again is to just make sure that either the x's or the y's are actually having the same value. So it is actually simpler for you to work out the unknowns which are both positive. It is actually easier that way. So that now here we have 4x, here we have 3x. To make them same, we normally do this. This 3 will multiply the first equation, and this 4 will multiply the second equation. So they interchange this value. This value goes upward and this one goes here, so that when we multiply, these x's are going to be the same. So we are going to have 12x minus 6y is equals to negative 9. And 12x plus 4y is equals to 12. Remember, these numbers actually multiply everything. Therefore, if we now subtract equation 1 minus equation 2, this is what we are going to have. 12x minus 12x is 0. But here you need to be very careful. We have negative 6 minus, because of this minus, 4y positive. So you'll find that this one is going to be negative 10y. So we have it as negative 10y is equals to, when we have negative 9 minus 12, it's the same as negative 21. So you say it's the same as negative 21. So we have here negative 10y is equals to negative 21. Therefore, y would be equal to negative 21 over 10, which can be simplified to be 2.1. So this is the value of y. Upon getting the value of y, you just come to one of the equations. Like for example, you can come to the initial equation of equation 2, where we had 3x plus y is equals to 3. And we know y is actually 2.1. Therefore, 3x plus 2.1 is equals to 3. Therefore, 3x is equals to 3 minus 2.1. Therefore, x is actually the same as 0.9. 3x, sorry, is equals to 0.9. So x is equals to 0.9 over 3. That is actually how we normally work them out. So by elimination, you must make sure that one of the values is completely eliminated or reduced to 0, so that you can work on the other value which remains, and before now substituting the value that you have obtained in one of the equations, so that you can get the equation or the solution for that particular equation by getting the values over the two unknowns. So basically that is elimination. Elimination makes sure that one of the values is completely eliminated for you to be able to work that particular equation. Unless one of them is eliminated, then it is not possible. So make sure one is eliminated, we remain with one, then we get the values respectively. So when we meet next, I'm going to give you the approach we normally use when we are solving these simultaneous equations, when we are using substitution method. For now, I want to thank you.